Lesson 5.3, friction. Okay, so first let's start by defining friction. Friction is a contact force, right? All that means is it happens between two surfaces that are touching or otherwise they're in contact, right? So friction is a contact force that resists the direction of motion, or it opposes. So if the direction of motion, I'll give you an example. If example 1, right? So if the motion of an object, say this is your box, and you pushed on this box with a force F push, right? So this box is going to the right, and the net force of the box is to the right. So then friction will act on this box to the left. It will be opposite the net force or opposite the direction of motion. This is the direction of friction, and we call friction Fr, or we usually refer to it as Fr. Let me give you another example, this time with multiple forces. So let's take example 2, this box right here, and I pushed on it with, say, F1 equal 30 Newton. And then from the other side, I went a bit less than that. I said, for example, say F2 is equal to 10 Newtons. Then you'd look at this and you'll say, okay, the net force is to the right because 30 minus 10, so I have 20 Newtons to the right. So friction opposes the net force. So friction in this case would be to the left. We're going to discuss two types of friction. The first type is what we're going to call static friction. The second type is what we're going to refer to as kinetic friction. And in some textbooks, they refer to kinetic friction as sliding friction. Okay, so let's start with static friction. Static friction, from its name, is the friction of an object that is static, or the friction of an object that is not moving. For example, say I have a heavy object, right, like a fridge or something. Okay, and this is you. You're trying to push this fridge, and you're on a very rough surface, right? Static friction is the force that's going to resist your push when you try to push on a table or whatever it is, right? Or in this case, a fridge. Static friction is the force that is resisting you so long as the fridge is still not moving, right? The second this fridge starts to move, you get a different kind of friction, right? So let's define that other friction. Kinetic friction, kinetic friction is the friction of a moving object. In the example above of you pushing a fridge, right? If suddenly you started moving this fridge, at this point in time, you no longer have static friction. The friction that opposes you is kinetic friction because it's moving. Okay, now you might ask, how can I calculate the static friction or the kinetic friction of an object? Well, let's start with static friction. To calculate the static friction, you'll say FRS, which is how we refer to the force of static friction, right, is less than or equal to, and I'll explain why we put the less than or equal to, Fn, which is just the normal force, multiplied with mu s. Now what mu s is? Mu s is a coefficient of static friction. It's just a number that tells you how rough your surface is. This is usually something that you will either find given or you will be asked to derive mathematically. Like they'll give you friction, for example, and they'll give you the normal force and they'll ask for the coefficient of static friction. We'll solve some exercises on this. As for the reason why it's a less than or equal to, it's because this Fn times mu s will give you the maximum value of static friction. So when I do the normal force times this coefficient of static friction, this will give me the maximum force that you can push on this object without it moving. So for example, if I got that the max static friction is equal to 100 newtons, if I pushed with 99 newtons, this object is not going to move. If I pushed with 99.9 newtons, this object is not going to move. If I pushed with 100.1 newton, right, this object will move. Anything greater than the max static friction will cause an object to move. If I push with anything less than, so for example, say I pushed this fridge right here in this fridge example, if I pushed with F push equals 20 newtons, this is less than the max static friction. So I know it will not move, and I know that the static friction in this case, FRS, is equal to 20. So long as the push is not greater than the max static friction, then the static friction will equal the push to keep this object at equilibrium. So for example, if I told you the push was 30 newtons, the static friction would be 30 newtons. That's why you have the less than or equal sign, because it depends on how much you push on the object. Now, as for kinetic friction is a bit easier than that. Kinetic friction is just FRK, K is for kinetic, is equal to Fn times mu k. This is stable. Mu k is the coefficient of kinetic friction for any surface, right? Every surface has a different coefficient of kinetic friction depending on how rough it is, right? So this is a constant value. No matter if an object is moving and you're pushing it with 500 newtons, it'll have the same coefficient of kinetic friction as if the object is moving and you push on it with, say, 20 newtons. Okay, so this is a simulation by FET Colorado. It's a pretty good simulation, and it should help you understand the concept of static and kinetic friction. So first off, you're going to push with 50 newtons. As you can see, the applied force and the frictional force are both 50 newtons, and this is currently static friction, right? If I increase the applied force, the static friction is increasing with it. Why? Because I have not yet reached the maximum static friction. So if I'm under the maximum static friction, the static friction can equal any force you push, so long as it's under the maximum, right? And it will keep doing that until you go above the maximum. So if we keep going, it's still not moving until we reach 100 and how much is it? Okay, and 127 newtons, it starts moving. And now suddenly, as you can see, the frictional force drops all the way down to 94. Why is that? It's because now this is no longer static friction, this is kinetic friction. And this kinetic friction will always be 94 newtons, as you saw in the formula. It's equal to the normal force times the coefficient of kinetic friction. So even if I increase the applied force, like say I make it 177, right? Look at this. The frictional force is still 94 newtons. If I decrease it, it's still 94 newtons. Compare this to the static friction. The static friction changes to equate whatever force you put to it, so long as that force is less than the maximum static friction. So let's just repeat that again. We said it can equate any force equal to it, but we realize here that the static friction, if you noticed, at 125, it's still not moving. So the static friction, you still have not reached the maximum static friction. At 126, it begins to move. That means that the maximum static friction, okay, the maximum static friction is 125.9 something newtons, or maybe it's 125 newtons exactly, right? The second you go above that threshold, the second you go beyond the maximum static friction, it becomes kinetic friction. And kinetic friction always has a lower value than static friction. Okay, so here's an exercise about friction. You have a 10 kilogram box sliding to the right. It says, because it says sliding to the right, and it's in motion, we can say that this is going to be kinetic friction. It says a horizontal force of 10 newtons is being applied to the right and gives you the coefficient of kinetic friction. It says 0.2, and it wants the acceleration. So let's just do what you should always do when it comes to dynamics. This is moving to the right, which is draw the free body diagram. So if you draw the free body diagram, you have a force of 10 newtons to the right. So this is 10 newtons. And because this is 10 newtons and it's going to the right, friction is opposite the direction of motion. So friction is to the left here, FRK. And then you've got the weight of the object as such, Fg, and you've got the normal force, Fn. And then all you have to do now is just say Fnet equals ma, and then you substitute the values. Fnet would be 10 minus the kinetic friction. Why is the kinetic friction minus? Because we're taking the positive direction to be right, and so any force that's pointing to the left or pointing downwards, in our scenarios, we're going to consider them as negative. So this is equivalent to ma. The mass is given. You have the mass is 10 a. And now we have to calculate the kinetic friction. Well, we know that kinetic friction is equivalent to the normal force, Fn, multiplied by the coefficient of kinetic friction, mu k. I can find the coefficient of kinetic friction. It's given. It's 0.2. And as for the normal force, if you look at the free body diagram, it's not moving on the y-axis, right? So the normal force is equivalent to the gravitational force, or the weight of this object. So this is just gravity, which we're going to say is 10, multiplied by the weight of by the mass of the box, which is also going to be 10. So this is just mg, right? So it's 10, which is the mass, multiplied by gravity, which for the sake of calculations we will say is 10, multiplied with mu k. So if you calculate this, you'll get that mu k is equal to 20. Now you just plug this into the equation. You're going to get 10 minus 20. So this is just be, this part right here is just 20. Right? So it's 10 minus 20. So minus 10 is equal 10a. So a is equal to negative 1, which means that I have a negative acceleration. What does that mean? It means I'm going to the left. I'm accelerating to the left at 1 meter per second squared. So it's just A. Acceleration is to the left. How do I know it's to the left? It's because I have that negative sign there. Okay, let's take another example. Right? Let's say I have an object right here, and the mass of this object is equal to 20 kilograms. And I tell you that this object is on a surface of roughness. I give you mu s is equal to 0.4, right? And I asked you, if I push this object with a force of 200 newtons, will it move? Right? That's the question. Will this object move? All you have to do in this scenario is to calculate the maximum static friction and check if it is greater than or less than this force. If the maximum static friction is less than 200, then it will move. If, on the other hand, the maximum static friction is greater than or equal to 200, this object will not move. So let's calculate it. I know that the static friction, FRS, the maximum static friction, is equivalent to Fn times mu s. It's not less than or equal to, it's equal to, because we're talking about the maximum static friction. We're not talking about static friction in general, right? I know that mu s is 0.4, and the normal force on this object will just be its mass. It will be equivalent to the force of gravity on it, right? Which would just be ma, right? Or sorry, mg, right? It's its mass times gravity, and we know its mass is 20. And for the sake of ease of calculations, we'll take gravity as 10, and we'll multiply this by 0.4. So you get FRS max is equal to 80, I believe. Equivalent to 80 newtons. And as you can see, 80 newtons is less than 200 newtons, and so this object will move. This is another type of exercise that you can get in for friction questions. Another type of question that they might ask is they might say, if I'm pushing an object, say this is your object, or say I have a box, right? This box is on a surface of an unknown static friction, okay? And I'm pushing this object, or I'm pulling on this object with a force of, say, 50 newtons. And I told you that the mass of this object is equal, I don't know, 6 kilograms. And I asked you, or let's not make it 6 kilograms, let's make it like 12 kilograms, right? And I asked you, or you were asked, what is the minimum mu s such that this box does not move? In this case, all you have to say, right, is you have to equate this 50 Newton force, or whatever force it is, because we know we have gravity to this side, right? Sorry, not gravity, we have friction to the left in terms of FRS, but we don't know what that friction is. All you have to say, since they're asking for the minimum value of mu s, is you have to say that FRS is equivalent to 50 newtons, and then you just solve. You just say, okay, FRS is equal to the normal force times mu s. So I have times mu s, and in this case, the normal force again is equal to mass times the gravity. So I told you that the mass is 12, so this is just 12 times 10 times mu s is equal to 50 newtons. So that means the mu s is equal to 50 over 120. If you just multiply 10 by 12, divide by that, so then you'll get mu s. Alternatively, you could just shift solve on your calculator. You'll get that mu s is equivalent to, or the minimum mu s is equivalent to about 0.416.
That'll be it for lesson 5.1 friction. If you have any questions or want to ask anything at all, you can ask it down below in the comment section or in the server. And yeah, good luck.